Welcome to Aviation World.
Welcome to this presentation covering the electrical system on A320 series aircraft. An efficient electrical system is critical for a highly computerized, modern commercial jet aircraft. The A320 series electrical system is similar in its basic design to electrical systems on other aircraft, but more automated in operation and easier to use. We will begin by discussing the basic design of the system. Let's start by looking at the sources of AC power. Two engine-driven generators are the primary source of AC power once the engines are running. Each engine-driven generator is connected to its engine's accessory section and maintained at a constant speed by an integrated drive generator. The IDG may be disconnected when necessary. Because the APU runs at a constant speed, no IDG is required. This terminology can be confusing to those new to Airbus. The IDG is not the generator itself, but a part of the generator system. You could think of it as the integrated drive of the generator. The IDGs are similar to those of constant speed drives on older generation aircraft. The electrical network can be also supplied by the APU-driven generator. This generator does not require an IDG due to the relatively constant operating speed of the APU. Any one of these generators, engine or APU-driven, are capable of powering the entire aircraft's electrical needs on their own. However, if only one generator is the source of power in flight, main galley power is automatically shed. On the ground, main galley power is not shed if the APU generator is the only source of power. This will be discussed in greater detail later in this lesson. On the ground, the entire electrical system can be powered by an external power source. AC power sources initially supply power to the two AC buses, AC Bus 1 and AC Bus 2. Shown here is the standard configuration when both engine-driven generators are operating. We can observe that the bus tie contactors on the cross-tie bus are open, effectively splitting the system in half. This allows Gen 1 to power items on the left side of the system. This includes items such as AC Bus 1, AC Essential Bus, AC Essential Shed, DC Bus 1, DC Bat Bus, Battery 1 and 2, DC Essential Bus, and DC Essential Shed. The AC and DC Essential buses are so named because they power items necessary for the safe recovery of the aircraft. This is important should there be a loss of normal electrical power sources.
Subscribe to our channel by clicking subscribe button. Also click the bell icon button to get notified directly for latest uploads.
If only Gen 1 is operating, the bus tie allows Gen 1 to power items on the right side of the system. This includes items such as AC Bus 2, DC Bus 2. Gen 2 normally powers items on the right side of the system. This includes items such as AC Bus 2 and DC Bus 2. If the AC Essential Feed push button is pushed, Gen 2 can provide an alternate power source for the essential buses, AC Essential Bus, AC Essential Shed, DC Essential Bus, and DC Essential Shed. More on this later in the lesson. If only Gen 2 is operating, The bus ties allow Gen 2 to power items on the left side of the system. When the Apu generator, or external power, is the only AC power source, the bus tie contactors on the cross-tie bus close. This allows either power source to power the entire system. These bus tie contactors also close when necessary to allow a single engine-driven generator to power the entire system as mentioned previously. In this example, external power is powering the entire system. An emergency generator, powered by hydraulic pressure provided by a ram air turbine, is the primary backup AC power source should normal power sources fail. The RAT pressurizes the blue hydraulic system, which powers a hydraulic motor that drives the emergency generator. The emergency generator provides AC power directly to the AC essential bus, and through the essential TR supplies DC power to the DC essential bus. As long as the emergency generator is running, the AC and DC essential shed buses will remain powered. The ship's batteries provide yet an additional backup source of electrical power should all primary power sources and the emergency generator fail. If that occurs, BAT2 automatically powers the DC essential bus directly. BAT1, through a static inverter, powers the AC essential bus. The AC and DC essential shed buses automatically shed to lighten the electrical load on the system. Each battery has an associated battery charge limiter. The BCL monitors battery charging and controls its battery contactor. A commonly used memory aid for the electrical priority logic is Gear B. The three types of circuit breakers are used to protect the system. The green circuit breakers are monitored by the ECAM. If they trip and are not reset within 1 minute, a circuit breaker tripped ECAM message is generated. Black circuit breakers are not monitored. The red circuit breakers are related to the wingtip brakes. The wingtip brakes engage if certain slat flap malfunctions occur. The red collar prevents the circuit breaker from being pulled. This completes the overview section. We now move on to the electrical system controls and indicators. The electrical system can be monitored by selecting the electrical key on the ECAM control panel. As with other systems, the page will automatically be displayed in some situations, abnormals. The primary AC power sources are depicted at the bottom of the electrical page. The engine-driven generators, Gen 1 and Gen 2, are displayed along with their IDGs. When a generator is selected on, the Gen label is white. The load, voltage, and frequency are normally displayed in green. The engine generators provide 90 kV per ampere, 3-phase, 115 to 200 volts, and 400 Hz. If any of these parameters is out of the normal range, the Gen label is displayed in amber. The load indication is displayed in amber if the load exceeds 100%. The voltage and frequency indications are displayed in amber if these parameters are out of the normal range. These green lines indicate that the generator is supplying power to its respective AC bus. In this example, Gen 2 is selected off. Notice the green line indicating that Gen 1 is now powering AC Bus 2 via the cross-tie bus. Note, depending on FADEC power status and whether or not the respective engine is running, the generator and IDG numbers may be displayed in amber. The IDGs are displayed below each generator display. Each IDG uses an independent closed oil system which circulates oil continuously through the IDG and a cooler. The IDG indications include the oil temperature, which is displayed in green when the temperature is in the normal range. The IDG's oil temperature pulses green as an advisory, and the electrical page is automatically displayed if the IDG oil temp approaches a preset limit. The IDG's oil temperature is displayed in amber, along with the IDG label if the temperature exceeds a limit. This is accompanied by an ECAM message on the EWD directing you to disconnect the affected IDG. If the respected engine is running and the IDG oil pressure drops below a preset limit, low pressure is displayed below the IDG label. This is also accompanied by an ECAM message on the EWD directing you to disconnect the affected IDG. If the IDG has been disconnected, disconnect is displayed below the IDG label. The engine-driven generator is no longer available. The IDGs cannot be reconnected in flight.
Subscribe to our channel by clicking subscribe button. Also click the bell icon button to get notified directly for latest uploads.
The Apu Gen load, volts, and frequency are depicted with the same logic employed for Generator 1 and Generator 2. In this example, the APU is running, the APU generator is operating normally, but the APU Gen is not supplying power to the system since both engine-driven generators are operating. The engine-driven generators have priority over the APU on their respective sides. Just like the engine-driven generators, the APU generators provide 90 kV per ampere, 3-phase, 115 to 200 volts, and 400 Hz. In this example, the Apu Gen is supplying power to the entire system through the cross-tie bus since both generators are not operating. The Apu Gen depiction changes significantly depending on the status of the APU and the Apu Gen push button on the electrical panel. In this example, the APU is shut down. In this example, the APU is running, but the Apu Gen push button on the electrical panel is selected off. This would be unusual because the Apu Gen is normally left in the on, lights out position. In this example, the APU is running and the Apu Gen push button is in its normal lights out position. However, because the engine generators are both running, the Apu generator is not supplying power to the system. When external power is not connected to the aircraft, the area to the right of the Apu Gen on the electrical page is blank. When external power is plugged into the aircraft, the external power depiction is displayed. In this example, external power is plugged into the aircraft, but not in use. The Apu Gen is powering the system. In this example, external power is plugged into the aircraft and is in use. Switching between external power and the indications of which power source are currently in use will be discussed in greater detail in the normal operation section. The major electrical buses are displayed on the electrical page. Each bus label is normally green. The label is displayed in amber if the bus is not supplied. The AC buses are displayed on the lower half of the page. The DC buses are displayed on the upper half of the page. Two additional buses, the AC Essential Shed and DC Essential Shed, will shed automatically when power sources have degraded. This is represented by the amber word shed only if the bus is shed. Shed is not displayed if the respective bus is powered. The essential TR and the emergency generator are normally displayed in white. They only become active in the abnormal situations, and more information is then provided on the ECAM. The emergency generator provides 5 kilovolt per ampere, 3-phase, 115 to 200 volts, 400 hertz. We will look at the essential TR and the emergency generator in more detail in the abnormal operation section of this lesson. The two primary transformer rectifiers, TR1 and TR2, are displayed just above the AC buses. The TR labels are normally white and the voltage and amperage readouts are normally green. The voltage readout is displayed in amber if the voltage moves outside the normal range. The amperage readout is displayed in amber if the amperage drops below a preset limit. The TR labels are displayed in amber if either the voltage or the amperage readout is displayed in amber. Also notice that the other TR automatically replaces the faulty one. At the top of the electrical page is a depiction of the aircraft batteries. If a battery is off, it is depicted as you see here. Remember that each battery has an associated BCL that controls its battery contactor. If the area between the battery depictions and the DC battery bus is blank, this means that the battery contactor that connects a battery to the DC bat bus is open and no current is flowing. A green line is displayed when the battery contactor is closed. However, a green arrow is not displayed if the flow is less than 1 amp. A green arrow pointing towards the battery indicates that the battery is taking a charge from the DC bat bus of 1 amp or greater. An amber arrow pointing away from the battery indicates that the battery is discharging current to the system at a rate of greater than 1 amp. Similar to the TRs, the BAT1 and BAT2 labels are normally white. The voltage and amperage readouts are normally green. The voltage readout is displayed in amber if the voltage moves outside the normal range. The amperage readout is displayed in amber if the discharge current is greater than 5 amps. The battery labels are displayed in amber if either the voltage or amperage readout is displayed in amber. We will now discuss the electrical control panel, which is located in the center of the overhead panel. The Gen 1 and Gen 2 push buttons can be used to select the respective engine-driven generator off when necessary. These push buttons are normally left in the on, lights out position. When the generator is operating normally, this allows the generator line contactors to close and connect the generators to the aircraft's electrical system when appropriate. The fault light illuminates if the push button is selected on and the line contactor is open. For example, both fault lights illuminate when the line contactor opens after engine shutdown at the gate. Illuminated fault lights are normal during the pre-flight. If a Gen push button is selected off, the generator field is de-energized and the line contactor opens. Advance to select the Generator 1 push button off. This will shut down the Generator 1. Gen 1 is now selected off. This position may also reset a faulted circuit, allowing the crew to attempt to bring a faulted generator back online.
Subscribe to our channel by clicking subscribe button. Also click the bell icon button to get notified directly for latest uploads.
The guarded IDG push buttons are normally lights out. Pushing one disconnects the respective IDG from the engine's accessory gearbox. If disconnected, the respective generator is lost for the remainder of the flight. An IDG can only be reset on the ground by maintenance, so you better be sure you push the right one, hence the guard. Caution: to prevent damage, an IDG push button must not be pushed for longer than 3 seconds, and the respective engine must be running or windmilling. The fault light illuminates and an ECAM message is displayed if either of the following occur: high IDG oil temperature or low IDG oil pressure. Advance to lift the guard and push the IDG 2 push button. Notice on the electrical page that IDG 2 is now disconnected. The fault light in the generator 2 push button indicates that the generator is offline. The Apu Gen Push Button operates in basically the same way as the Gen 1 and Gen 2 push buttons. It is normally left in the on, lights out position to allow the Apu generator to power the electrical system when it is available and appropriate. You will rarely, if ever, push this push button. The fault light illuminates and an ECAM message is displayed if the APU is running and the Apu Gen Push Button is selected on and the line contactor is open. The external power push button allows the crew to monitor the status of the external power and to connect or disconnect it from the electrical system when necessary. The avail light indicates that external power is plugged into the aircraft and the external power is within parameters. The avail light does not indicate that external power is supplying the electrical system. It only means that it is plugged in. The external power push button must be selected on to supply the electrical. Advance to select the external power push button to the on position. Note that external power has priority over the APU gen and comes online to power the entire system. Don't allow yourself to be fooled by the avail light. Here is a classic example of how it can be misleading. You have just arrived at the gate with the APU running and you have just shut down both engines. You see that the external power is available, so you incorrectly decide to shut down the APU. Advance to shut down the APU and its generator by pushing the APU master switch push button. You have just shut down AC power to the aircraft. External power could not take over from the APU gen because the external power push button was not first selected on. A similar mistake can occur prior to pushback when the ground crew wants to pull the external power cord. The APU is running, but the external power is still in use. You should deselect external power prior to the ground crew pulling the cord. This will prevent arcing and sparks that could injure ground personnel. To deselect external power, check to ensure another power source is available, unless you are trying to shut down the aircraft. In this case, the APU is running and ready to go. If the external power cord were accidentally unplugged, the APU would automatically power the electrical system because it is available. However, unplugging the power cord when it is still in use is poor technique and dangerous. Advance to deselect external power by pushing the external power push button. The on light extinguishes, the avail light illuminates, external power is still plugged into the aircraft, and the APU gen is now powering the electrical system. Remember that the APU gen push button is normally left in the on position. If the APU is running, the APU gen will also be running. Because of the priority logic, you can see that the external power push button is used to transfer to the APU power. This is a very important concept to understand. Assuming both engines are off and all push buttons are in their correct positions, 2 avail lights means that the APU will be powering the aircraft. This is another very important concept to understand. Also, if the APU were to auto shutdown, the external power would not power the system. Remember that the external power will never power the system unless ON is illuminated. This can be confusing because it is opposite of the APU indications, avail versus ON. The AC essential feed push button is normally left in the lights out position. It is used in the course of certain electrical system abnormal procedures to allow AC Bus 2 to provide power to the AC Essential and AC Essential Shed buses. We will discuss the AC Essential Feed push button in more detail in the abnormal operation section. The bus tie push button is normally left in the lights out position. The bus ties are not depicted on the electrical page. Visualizing them as you see here can help you to understand their function. If the bus tie push button is selected off, both bus ties open and neither external power nor the APU generator can supply the electrical system. With the bus tie push button in auto, the ties can open and close as necessary. In this example, they are both closed to provide external power to the entire electrical system. We will discuss the use of the bus tie push button in more detail in the abnormal operation section. The galley power push button is normally left in the auto lights out position. In the auto position, the main galley, secondary galley, and in-seat power are supplied. The main galley and in-seat power are shed automatically if only one generator is operating. The secondary galley remains powered. You will have hot coffee. An exception to this is when the aircraft is on the ground and either the APU or external power are supplying the electrical system. In that case, the entire electrical system is powered. The galley push button fault light illuminates accompanied by an ECAM message when the load of any generator is more than 100% of rated output. The ECAM message would include a step that requires you to select the galley push button off. Advance to select the galley push button off. Selecting the galley push button off depowers the main galley, secondary galley, and in-seat power. In other words, all galley power has been selected off. This should reduce the load on the generator. In this example, we are in flight and generator 2 has been selected off. As previously mentioned, the main galley and in-seat power are automatically shed. However, secondary galley power remains available and will power smaller items such as the coffee makers. Finally, we arrive at the battery voltage indicators and the battery push buttons at the top of the electrical panel. The battery voltage indicators show the current voltage of each battery. They are connected to the hot battery buses, so they are always available even if the battery and other power sources are off. A readout of battery voltage is also available on the electrical page. However, if all power to the aircraft is removed, the electrical page will obviously not be available. The BAT1 and BAT2 push buttons control the operation of their corresponding battery charge limiters. The battery charge limiters automatically control the connection and disconnection of the corresponding battery to the DC BAT bus by closing and opening the battery line contactors. With the battery push buttons in their normal auto, lights out position, the battery line contactors close, connecting their respective battery to the DC BAT bus. For APU starts, limited to 3 minutes if operating on emergency generator. If battery voltage is detected to be below 26.5 volts, to allow for battery charging, and The battery line contactors also close. On the ground, when AC bus 1 and AC bus 2 are not supplied, this allows the batteries to supply DC power and limited AC power through the static inverter prior to APU start if external power is not available. In flight, if AC bus 1 and AC bus 2 are not supplied and the emergency generator is not operating, worst case emergency electrical power scenario. During normal operations, the contactors are open most of the time. Automatic battery cutoff logic prevents the batteries from discharging completely when the aircraft is on the ground. This cutoff logic automatically opens the battery contactors if all of the following conditions are met. The aircraft is on the ground, the BAT push buttons are in auto, an AC power source is not available, and battery voltage is low. The crew can reset the contactors by selecting the BAT push buttons off, then to auto. With the BAT push button selected off, the battery line contactors are open and the charge limiters are not working. Without power on the aircraft, it is difficult to determine if the batteries are off. This is because the off lights require power to illuminate. But if the batteries are in auto, the off light will also not be illuminated. In this situation, you have to use an alternate method to determine if the BAT push buttons are in off or auto. If the batteries are selected to auto, the push buttons are slightly recessed into the panel. They are latched in the auto position. The green landing gear down lights illuminate. Some cockpit lighting is available. In this example, the batteries are in auto. If the push button is flush with the panel, the push button is in the off position. In this example, the batteries are off. Advance to select BAT 1 to auto and observe the effects. When the BAT push button is selected to auto, the off light in the other BAT push button illuminates. The fault light in a BAT push button illuminates, accompanied by an ECAM message, if the charging current for the corresponding battery is outside normal limits. The battery contactor will open automatically. We now move on to the emergency electrical power panel located on the left side of the overhead panel. The guarded emergency generator test push button is used by maintenance personnel to test the operation of the emergency generator. The Gen 1 line push button allows the crew to control a special circuit that dedicates Gen 1 to power only one fuel pump in each wing. It is used as part of the procedure for the avionics smoke abnormal. The red fault light on this panel illuminates if all of the following conditions are met. The aircraft is in flight, AC1 bus and AC2 bus are not powered, the emergency generator is not supplying power, which it should be doing. In that case, the guarded RAT and emergency gen man-on push button could be used to attempt to manually activate emergency gen. We will see this fault light and push button again in the abnormal operation section. The external power panel near the nose gear provides two lights used by ground personnel to monitor the status of external power. The white not in use light illuminates if not currently supplying the aircraft's electrical system. This provides them with a confirmation along with the captain's verbal assurance that it is safe to remove external power. The amber avail light illuminates if external power is available for the crew to use and the voltage is correct. In this example, the avail light in the external power push button in the cockpit would be illuminated because external power is connected but not being used. In this example, external power is connected, the voltage is correct, and is currently powering the aircraft. The on light in the external power push button in the cockpit would be illuminated. It is also possible to energize the electrical circuits for ground servicing without energizing the entire aircraft electrical system. This can be accomplished using the maintenance bus switch located on a panel in the ceiling area of the forward galley. In the on position, the switch latches magnetically if external power is connected. The on position allows only the AC and DC ground flight buses to be powered. Some of the items available in this configuration include passenger lighting, galley lighting, entrance area lights, lavatory lighting and service, vacuum cleaner sockets, cockpit outlets, yellow hydraulic pump, cockpit flood lighting, fuel quantity indicators, cargo lighting, landing gear compartment lighting, belly, fairing panel outlets, ground call, equipment compartment lights and service outlets, and navigation lights. The switch trips off when the external power is removed. In the off position, the AC and DC ground flight buses are connected to AC Bus 2 and DC Bus 2. The AC and DC ground flight buses not depicted on the electrical page. This completes the controls and indicators section.
Please visit our website www.part66easa.com for the Part 66 exam preparation. All latest study material, sample question papers, online test series, ebooks are available for free. Thank you for watching this video.